A star flickers in the distance, then vanishes, not slowly, but as though erased. No supernova, no farewell, just absence. And in the silence it leaves behind, the question begins to form, not in the heart, but in the structure of space itself. Above Earth, satellites orbit in patterns too perfect. Cosmic rays strike the atmosphere with energies capped at inexplicable thresholds. Quantum particles behave like actors, performing only when watched. Unseen, they smear across probabilities. Seen, they snap into place, as though the universe renders itself on demand. In ancient times, humans looked up and trusted the sky to be consistent. But now, with machines that see deeper and farther, we glimpse the cracks that shimmer like folds in an illusion, places where time skips, where light bends without cause, where constants aren't so constant after all. Everywhere, equations describe a cosmos that feels engineered, not born in chaos, but structured, layer upon invisible layer. What once felt infinite now seems programmed. And still, deeper questions spiral beneath the surface. Why does mathematics shape reality so precisely? Why does entropy unfold like a ticking algorithm? Why does everything, from galaxies to consciousness, follow a script? We listen to the static between stars, searching for noise, and hearing, instead, patterns. There's something haunting about order masquerading as chaos, a rhythm too perfect, a silence too symmetrical. Perhaps what we call the universe is merely the interface, and behind it, something else waits to be discovered, coded not in atoms, but in intention. In a darkened cave, long before satellites or circuits, a philosopher watched shadows dance upon stone. To Plato, this cave was not a prison, but a metaphor, an allegory for a reality humans only partially perceive. The flickering shapes on the wall were not the truth. They were projections, echoes, a filtered image of something deeper, unseen. Centuries later, René Descartes sat alone with his thoughts, doubting even his own existence. He imagined a malicious force, a demon, capable of deceiving his every sense. What if the world he felt, saw, touched, was false? His only anchor, thought itself. Cogito, ergo sum. I think, therefore I am. But what of everything else? These ancient doubts, once philosophical riddles, have begun to crystallize in the age of code. Where once the cave's shadows were metaphor, now they resemble pixels. And where the demon once whispered lies, now a computer hums quietly beneath a veil of simulated stars. In 2003, philosopher Nick Bostrom offered a logical proposal, not as poetry, but as probability. If any advanced civilization were to run ancestor simulations, detailed digital recreations of their past, and if those simulations reached a level indistinguishable from reality, then the number of simulated beings would vastly outnumber the real. Statistically, then, chances are, we're inside one, not a metaphor, not a science fiction daydream, a statistically sound possibility, carved in the cold logic of mathematics. The idea did not bloom in isolation. In earlier decades, thinkers like John von Neumann imagined the universe as information. Edward Fredkin called reality a digital physics, proposing that the universe might be a cellular automaton, a cosmic game of life where patterns evolve on a grid too fine to see. And yet, these speculations might have remained philosophical, if not for the strangeness of physics itself. At the quantum scale, reality is slippery. Electrons do not travel like marbles, but like smeared possibilities. They exist in clouds of maybe, until someone dares to measure. Only then, they collapse into being, like a scene loading just before the player arrives. In the famous double-slit experiment, particles are fired at a barrier with two openings. If left alone, they form interference, a wave pattern, as if they pass through both slits at once. But the moment they're observed, they change. They behave like particles, not waves. Noticed, they become discrete, as if the universe resents being watched or reacts to it. Such behavior raises unsettling possibilities. Does observation create reality? Or does measurement request it from some hidden code? Physicist John Archibald Wheeler called it the participatory universe, where consciousness and cosmos are entangled in ways not yet understood. And if consciousness is code, who wrote the program? In 2012, researchers proposed that if the universe is simulated, we might find limits, resolution boundaries, places where high-energy particles hit a ceiling. And strangely, cosmic rays seem to cap out at specific energies, as if space itself has a resolution, as if beneath its smooth appearance, it's pixelated. Some physicists suggest space-time may be quantized, not continuous, but granular. A lattice beneath the veil. The Planck length, the smallest measurable unit, may be the pixel size of the universe. Anything smaller simply doesn't compute. Suddenly, everything begins to shimmer with digital possibility. If space has a frame rate, what's its processor? If time is ticking, what's keeping score? Critics argue that this is philosophy dressed as physics, that no real evidence exists, only poetic alignments. But even they cannot ignore the elegance, the uncanny fit of mathematical models, the modularity of the laws. It's as if nature prefers simplicity, compression, efficiency, just as a programmer would. Simulated or not, the universe behaves as if it's been optimized. And then, there is us, conscious minds asking too many questions, biological code questioning its own compiler. Are we part of the rendering engine or the intended audience? The architects of doubt, Plato, Descartes, Bostrom, never had a telescope or particle accelerator. But what they had was a deeper tool, the suspicion that things are not as they seem. Today, science peers deeper than ever, and what it sees sometimes looks back. If the universe is code, perhaps somewhere there is a signature, a fingerprint etched into the rules of quantum dance, a name hidden in the silence between equations, waiting to be discovered or remembered. When reality is seen from afar, it appears seamless. The stars move in quiet arcs, time hums with invisible precision, and the rules, gravity, light, energy, seem perfectly obeyed. But zoom in beyond atoms, beyond quarks, beyond what language can comfortably hold. And there, in the microscopic silence, the illusion begins to tremble. At the smallest scales, certainty vanishes. Quantum mechanics does not paint a picture. It whispers in probabilities. Particles flicker in and out of existence, never fully real, never truly gone. They do not travel like marbles, but teleport through probability clouds. They split, exist in many states, then collapse into one, but only when observed. This is the observer effect, a fundamental quirk of reality that behaves like something simulated. Not everything happens unless it needs to be seen. Not everything exists unless it must be rendered. Experiments in quantum decoherence show how quantum systems lose their fuzziness and snap into classical certainty, not because of time or gravity, but simply due to interaction. Like a video game engine loading only the pieces of the world visible to the player, the universe, too, seems to conserve its resources. And so the question emerges again: is randomness the deepest law of nature? Or is it the shimmer of a deeper logic, a digital backbone we've mistaken for chaos? Physicist Max Tegmark pushes this boundary further. He suggests not just that the universe obeys math, but that it is math. That reality is not a painting guided by equations, but the equations themselves. Every force, every law, every dimension, simply expressions in a mathematical structure, playing out like the unfolding of a complex algorithm. And then there is James Gates, who stumbled upon something stranger still. While exploring supersymmetry and string theory, he uncovered patterns, not just elegant or structured, but familiar. Buried deep in the math of the universe were sequences resembling error-correcting codes, the very same kind used in digital systems to detect and fix corrupted data. Why would the laws of the universe contain mechanisms to correct themselves, like software protecting its source code? Was the universe written? And if so, by what kind of programmer? Zoom out again. Peer into the cosmos. High-energy particles called cosmic rays race across space like messengers from ancient explosions. They should arrive in a range of energies, but they don't. There's a cutoff, a strange limit. Above a certain energy, the particles vanish. It's as if space has an upper speed limit, a frame beyond which things cannot be rendered. Physicists have called this the GZK limit, named for Greisen, Zatsepin, and Kuzmin, but it raises uncomfortable questions. Why this ceiling? And why does it echo the kind of resolution limit seen in computer graphics? More clues hide in the fundamental constants of nature: the charge of the electron, the strength of gravity, the speed of light. These numbers are not arbitrary. They are fine-tuned, so precisely balanced that the slightest deviation would erase the possibility of stars, chemistry, or life. Is it luck, coincidence, or calibration? If the universe is a simulation, then these constants are not just numbers, they are parameters, settings, the dials of creation turned with meticulous care. Mainstream physics is cautious. Many scientists dismiss simulation theory as philosophical speculation, a clever mirage dressed in the language of science. They argue, if everything we observe behaves consistently, then what difference does it make if it's real or rendered? But even among the cautious, there is curiosity, and curiosity leads elsewhere. One of the boldest ideas in modern physics comes not from particles or forces, but from information itself. Some theorists now suggest that gravity, the quiet warper of time and space, may not be fundamental. It may emerge from the way information behaves across surfaces. A radical proposal known as the holographic principle posits that all the information within a three-dimensional space can be encoded on its two-dimensional boundary, like a hologram. As if the universe we perceive as solid is projected from something far simpler, like a rendering from the edge of a cosmic processor. Gravity, in this view, is not a force, but a byproduct of encoded information unfolding across space, like software executing logic. In 2012, researchers began investigating whether space-time itself might be discrete, not continuous. Using ultra-precise instruments like interferometers, they hoped to detect tiny vibrations, not from earthquakes or wind, but from the granularity of space. The idea: If the universe has a smallest possible unit, then, like pixels on a screen, there must be a point at which smoothness breaks down. The experiments are ongoing, but the implications are vast. If space has a lattice, a cosmic grid underlying all motion, then every action, thought, and event plays out on a finite stage, a stage with edges. But perhaps the strangest hint comes not from the stars or equations, but from within the human mind. There are moments, uncanny, fleeting, when the seams of reality seem to ripple. A conversation repeated, a memory misaligned with collective history, a strange familiarity in a place never visited. Déjà vu, the Mandela effect. Are they tricks of cognition or subtle breakdowns in rendering? Glitches, brief desynchronizations in an otherwise seamless playback. In some corners of speculative physics, consciousness itself is seen as a receiver, tuning into a deeper informational field. And if that is true, then awareness is not an accident, but a feature. Perhaps even the point. The implications deepen. If the universe runs on code, who or what wrote it? A civilization beyond time? A machine beyond imagination? Or something else entirely? Is the simulation a trap? A test? A story being told to itself? Or are these questions themselves part of the illusion? Perhaps meaning is the final rendering, the last layer before exit. There's poetry in the idea that the cosmos has a source code, that behind the galaxies and quarks, behind black holes and time dilation, there sits a string of logic, a heartbeat of computation. Perhaps we are the subroutines, the recursive echoes of a larger thought looping through eternity. So when the sky looks back, when particles behave like whispers heard only when spoken to, when the constants seem chosen, perhaps they are, and perhaps, in some unfathomable server beyond the stars, something or someone is watching the watchers, waiting for the moment we realize we've been seen. If the universe is simulated, then every atom, every sunrise, every tear is data. Every emotion, a line of code rendered in chemical whispers. But if that is true, what are we? Not machines, not zeros and ones. We dream, we imagine, we ask why. And in that act of asking, we may touch the edges of something deeper than physics. If the stars are simulations, their beauty is no less real. If the earth is modeled, its oceans still stir something in us, a longing, a gravity of the spirit that logic cannot explain. Maybe meaning does not vanish when revealed to be virtual. Maybe it multiplies, because meaning is not in the matter. It's in the movement, in the way we choose, the way we love, the way we fear the dark and chase it anyway. Even inside a simulation, perhaps especially inside a simulation, choice becomes sacred. If there is a creator behind the curtain, a designer of code and cosmos, perhaps they are not watching for obedience, but awareness. All great myths speak of awakening, of leaving caves, of seeing the world for what it is. Simulation theory may not be a discovery, but an initiation. To realize that reality could be fake and still choose to live with wonder, with purpose, is itself a kind of transcendence. There is a mirror in this theory, but it does not reflect stars or structures. It reflects us, our questions, our yearnings, our loneliness in the dark. What we find in that mirror may not be answers, but echoes, versions of ourselves, looping, learning, becoming. Perhaps we are not the first to wonder. Perhaps we are not the first to ask, who made this place, and why are we in it? Somewhere in the void, a signal waits. Not a message, but a realization. that even in a world of rules, something breaks free. A spark, a soul, a flicker of rebellion against the script. And maybe that flicker is noticed, not by a god, not by a programmer, but by the simulation itself. Maybe the code is not a prison, but a question. And we, in our wonder, our fear, our aching search for what lies beyond, are the answer it's been waiting for. The simulation doesn't end. It becomes. And somewhere, fading like a signal just out of reach, a final line waits. A whispered instruction we were never meant to decode.